In this paper, we use a team of mobile robots to detect and localize an unknown number of targets in an environment. There are many real-world applications where the number of targets is unknown, such as security and surveillance or search and rescue, where the team searches for survivors after a disaster. We propose an information-based receding horizon control law that allows the team to autonomously perform this exploration task. This video shows a typical simulation run, with the robots and the target estimate in the map on the left, the expected target cardinality in the upper right, and the entropy of the distribution over targets in the lower right. The team initially believes that there are 30 targets, and that targets have a uniform likelihood of being at any location within the environment. The robots are shown as the red triangles, which begin in the upper left corner of the map. The robots are equipped with bearing-only sensors, and the bearing measurements are the yellow rays emanating from the robots. These sensors are unreliable, sometimes failing to detect targets within the field of view, or returning false positive measurements to clutter objects. The robots are also unable to uniquely identify individual targets, making the data association problem difficult. We use the PhD filter to simultaneously detect the number of targets and their locations using these noisy sensor measurements, without any need to explicitly solve for the data association. The resulting estimate of the target locations is shown as the blue background, with the size of the dots indicating the expected number of targets at that location. Initially, there is a small possibility of a target being at any location, and targets that are well localized appear as large dots. The team uses the information-based control law to determine the sequence of actions that will improve the estimate of the targets the most. The robots consider actions over a range of length scales, allowing them to repeatedly measure a small region, or to take measurements of distant regions. These actions are shown as the light blue lines emanating from the robots, and the purple lines are the selected actions. After completing a fraction of the joint action, the team replans their actions. The team sequentially plans over robots within the team, significantly decreasing the computational complexity of the control law. The team ceases exploration when the robots have sufficiently high confidence in their estimate of the targets, as measured by the entropy of the distribution over targets. This confidence threshold is shown as the dashed line in the entropy plot in the lower right. As we can see from the target cardinality plot in the upper right, the robots are able to quickly determine the number of targets and spend the remainder of the time improving their estimate of the target locations. In the end, the team successfully determines the true target cardinality, which is 15, and localizes the targets to within 10 centimeters. The red diamonds show the true target locations.